Good day, Doctor. My name is Jelly Wong Ling Ling with the matrix number KH20033. Today, I will present the introduction part for the mini project 2, which is circuit analysis by using the mesh analysis and simulator. First of all, the mesh analysis or the mesh currents, also known as the root current method. For the root current method, it is a method that is used to solve the planar circuit for the currents and indirectly the voltage at any places in the electrical circuit. The root currents is a mathematical quantity rather than actual physical currents that are used to make the circuit analysis. And then this loop analysis will be used to find the unknown quantity in the circuit. Loop current method involves the four steps to find the current. For the first step, we will assign a current in the counter-clockwise directions around each non-redundant cross loop, although the direction of an assigned loop current is arbitrary. As we can see in the diagram, the IA and IB is assigned in the counter-clockwise directions, and then this may not be the actual current directions, but it does not matter. And then the IA and IB are in positive directions through the R2. This is because R2 is a common path for the both loops. And the number of the loop currents assignment must be sufficient to include the currents through all the components in the circuit. For the next step, the voltage drop polarity in the each loop is indicated based on the assigned current's direction. But in reality, the outthrough currents cannot be separated into two parts. But remember that the loop results are basically mathematical quantity and used for analysis purpose only. The polarity of the voltage resources are fixed and are not affected by the current assignment. For the third step, the Kirchhoff voltage law is applied in the each cross loop, and then this law will arrive a set of equations. For the each loop, more than one loop current passes through a component, and each voltage drop is included in one equation. For example, the equations for the loop A in the diagram below is R1 IA plus R2 bracket IA minus IB equal to Vx1, while for the loop B is R3 IB plus bracket IB minus IA equal to negative Vx2. And then for the next step is the resulting equations for the loop currents is solved by using the substitutions of determinants. For the power, it is a combination of the both voltage and the currents in a circuit. In the electrical circuit, the power is the rate at which energy is absorbed or produced within the circuit. The source of energy, such as the voltage, will produce or deliver the power while the connector lobs absorb. And then for the power, can be calculated by using the formula W over T, P equal to IB or P equal to IR squared, where W represent the watt, T represent the time, I represent the current, V represent the voltage, and R represent the resistance. That's all from me. Thank you.
Hi, I am Muhammad Muhammad Safri. My ID number is KH20030, and I will be explaining to you about the circuit drawing that we use in this project. So first of all, a little bit something about the circuits. We are going to use series circuit and parallel circuit all together while containing loops in them. So about these loops, it is when you got two or more voltage supply or battery in your circuits that are not in different places. Like for example, like this for series circuit and this for parallel circuit. So for this circuit drawing, we attach to use both of them, both series and parallel circuit that contains loop in there, and together. So I already showed you the overall drawing. Then I will be explaining to you about the formation. So first of all, I'm using 3 battery in total. First we got battery with 3 volts and 5 volt, and lastly 10 volt. Next we got 7 resistors with different resistance each. So we named each resistor corresponding to their number. So R1 starting with 5.7 ohm, R2 with 2 ohm, then R3 with 8 ohm, R4 with 0.7 ohm. Next we got R5 with 6 ohm, then we got R6 with 4 ohm, and last but not least we got R7 with 4.3 ohm. So for the formation of the loops in this circuit, first of all we got loop number 1 that contains a battery with 5 volt and 2 resistance, R1 5.7 ohm and R2 with 2 ohm. This R1 and R2 will be connected to each other through parallel. Yes. Next, for the loop number 2. Loop number 2 will contains a battery with 3 volt, that's earlier, and R3 8 ohm, R7 4.3 ohm. R3 will be connected to R7 through series, and in this loop also will connected to loop 1. So the loop will be look like this, and connected to loop 1 look like this. Next we got loop number 3. Loop number 3 will be supplied with voltage of 10 volt, and we got resistance of R4 0.7 ohm, next R5 6 ohm, R6 4 ohm, and last but not least R7 with 4.3 ohm. All of these resistance R4, R5, R6 and R7 will be connected to each other through by series. So that's why the circuit will look like this. That is all from me. Thank you.
My name is Radhashini and I'm from Point R Subimaran with the matrix number of KH20026. I would like to present about calculation of power. So based on the mesh current method, we have formed loop equations for loop 1, loop 2 and loop 3 based on our circuit. So as for loop 1, first of all, IL1 refers to current flow in loop 1, IL2 refers to current flow in loop 2 and IL3 refers to current flow in loop 3. For loop 1, negative 5 plus 5.7 IL1 plus 2 IL1 minus IL2 is equal to 0. Loop 2, negative 3 plus 2 times with IL2 minus IL1 plus with 4.3 times with IL2 minus IL3 plus 8 times with IL2 is equal to 0. Loop 3, 6 times with IL3 plus 0.7 times with IL3 plus 4.3 times with IL3 minus IL2 plus 400 times with IL3 minus 10 is equal to 0. So as we rearrange the equations here, for loop 1, 7.7 times with IL1 is equals to 2 times with IL2 plus with 5. This will be considered as our equation 1. For loop 2, negative 3 plus 14.3 IL2 minus 4.3 IL3 divided by 2 is equals to IL1. So this is considered as equation 2. For loop 3, IL3 is equals to 4.3 times with IL2 plus with 10 divided by 15 is equals to equation 3. So as we substitute equation 2 into equation 1, we are forming a new equation where we refer this as equation 4. 7.7 times with negative 3 plus 14.3 IL2 minus 4.3 IL3 divided by 2 is equals to 2 times IL2 plus 5. Then after substituting equation 3 into equation 4, in order to find our current in loop 2. After solving the equations, we will be getting 1449.277 IL2 will be equals to 827.600, where our IL2 current in loop 2 is equals to 0.571 amperes. So as we have the value of the current in loop 2, we can substitute IL2 into equation 1 to get IL1. So as we substitute, the value for IL1 is equals to 0.798 amperes. Then after, in order to find IL3, we are substituting IL2 into equation 3, which is IL3 is equals to 4.3 times with IL2 plus 10 divided by 15. So our answer for IL3 is 0.830 amperes. So as the current flow in all the 3 loops was calculated based on the Ohm's law, so using Ohm's law V equals to IR, we are going to calculate the voltage at each resistors: resistor 1, resistor 2, resistor 3, resistor 4, resistor 5, resistor 6 and resistor 7. So at resistor 1, V1 equals to IL1 R1, Ohm's law. So V1 is equals to 4.549 volt. At resistor 2, V2 is equals to 1.596 volt. And at resistor 3, V3 is equals to 4.568 volt. At resistor 4, V4 is equals to 0.581 volt. At resistor 5, V5 is equals to 4.980 volt. At resistor 6, V6 is equals to 3.320 volt. And lastly, at resistor 7, V7 is equals to 3.569 volt. So as we have already found the values of volts and currents at each resistor, now we can calculate the value of power at each resistor by using the formula of P is equals to IV. So at R1, using the formula P equals to IV, P1 is equals to IL1 V1. So P1 is equals to 3.630 watt. At resistor 2, P2 is equals to 1.274 watt. At resistor 3, P3 is equals to 2.608 watt. And at resistor 4, P4 is equals to 0.482 watt. At resistor 5, P5 is equals to 4.133 watt. And at resistor 6, using the same formula, P6 is equals to 2.756 watt. And at resistor 7, P7 is equals to 2.962 watt. So those are the calculations that should be made in order to find power in resistors. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil Farhan Al-Mustafi. My ID is KH20024. Today I want to present to you guys about my group simulation result. For this project, my group decided to use the FASTA software as our main platform to do our simulation. As you can see, you can use this type of link to go to the page of the website that shows our circuit that our group has been working for. Okay. Our group decided to use this FASTA software because it's very benefit for a student. One of it is the command is very manageable, simple, easy to understand, and on top of that, the most beneficial for us is the result and the data that we can use from the page or from the software is very easy to extract. All of the data that we use in this report were extracted from the software. Okay, back to the main point. As you can see, for this project, we are using a combination of a parallel circuit and a series circuit that is supplied with three different sources, which is 5 volt sources, 3 volt sources, and 10 volt sources. We decided to use for this project 3 different loops. This is the first loop, and this is the second loop, and this is the last loop, the third loop. As for the first loop, we decided to use two different values of resistor that has been arranged parallelly, which is 5.7 ohm resistor and 2.0 ohm resistor. The first loop has been powered by sources of 5 volts, and for the second loop, all the resistors in loop 1 are also connected by series to the 8.0 ohm resistor and 4.3 ohm resistor. Second loop is powered by the 3 volt sources. As the final loop, which is the third loop, we use 0.7 ohm resistor and 6 ohm resistor connected by series to 4.0 ohm resistor and 4.3 ohm resistor. The final loop is powered by the 10 volt sources. And after that, we jump to the simulation result. We get the result for the first loop is the current that we can get from the first loop is 3.299 ampere. As we know, the first loop we use 5 volts of as their sources, and the power that we can get from the first loop is 86.494 watt. And for the second loop, we get the current for the second loop is 78.309 milliampere, and we know that we use the sources for the second loop is 3 volts, and the power that we get from the second loop is negative 234.926 milliwatt. And finally, for the last loop, and which is the third loop, we get the current for the third loop is 989.115 milliampere, and we use the sources of this loop is 10 volts, and the power that we can get from the last loop is negative 6.891 watt. Okay, that's all for me today. Thank you.
Hi everyone, I am BINTI. My ID number is KH20031. Okay, for my part, I will present the comparison table of calculated and simulated results. Okay, this is show our result from this project. What you can see from this table, which is we divided in 3 loops. R1, R2 in loop 1, R3, R7 in loop 2, R4, R5, R6 in loop 3. Okay, we use the mesh current method to get all the values for all the values of current, voltage and power for all the resistor. So based on the mesh current method, the value of current in loop 1, loop 2 and loop 3 is obtained. Okay, for the second table, this is show the value of simulated result. We also use a simulator in our circuit project. So that is the simulated result. We got all the values of current, voltage and power for all the resistors. Okay, most of the value of simulated result in loop 1 is higher than manual calculated value, but manual calculated value for loop 2 and loop 3 is higher than simulated results. Okay, so I will continue for the part of calculation from this project. Okay, so what we can conclude from this project. Okay, in this project we have calculated our values for current, voltage and power in the 3 loops, and we verify the results by doing this project. From our circuit analysis, we have divided in 3 loops, which are for R1, R2 in loop 1, R3, R7 in loop 2, while R4, R5, R6 in loop 3. Okay, we also have calculated all the values in 3 loops by using mesh analysis and simulator. Okay, mesh analysis, or we call as mesh current method, is same as the loop current method, which is quite similar to the branch current method in that uses simultaneous equation, Kirchhoff voltage law and Ohm's law to identify all the announced current in a circuit. Okay, in mesh analysis, we also have defined a set of mesh currents and use the Ohm's law, V equal to IR in term of all the voltage. Okay, so from my previous slide, what we got is we also calculated the current of loop 1, loop 2 and loop 3 by manually using the mesh analysis current method, and we calculate the 3 loops also by using a simulator. So from that we got a small difference between values of manually calculated and simulated result for the 3 loops, which is loop 1 is have a higher value from the loop 2 and loop 3. For lastly, we got the objective of this project is accepted. The circuit analysis can be defined by using mesh analysis and simulator. Okay, that's all for our presentation project. Thank you.